Hi guys, good morning. So in the last session, we started with our module one, which is about L2 forwarding. Okay. So in L2 forwarding, we have seen about how you can create a VLAN, right? Then some show commands related to VLAN like show VLAN brief, show VLAN summary, VLAN ID and VLAN number, and then name of the VLAN. Okay. These are some of the show commands which we can use for troubleshoot. Correct. Then after access ports. Access ports also we have discussed that access port, they are a member of single VLAN only and they can forward the traffic for a single VLAN. They cannot forward traffic for different VLANs or multiple VLANs. Okay. So you can see an access port is assigned to only one VLAN and it carries traffic from the specified VLAN to the device connected to it, or from the device to other devices on the same VLAN. That means basically one specific VLAN traffic it will carry. Okay. Now, your catalyst switch ports, they are layer 2 by default. Even if you are using a multi-layer switch also, your switch ports are L2 by default. They are not working as a L3. Okay. So how we can use or how we can configure a port as an access port? We can use the command switch port mode access, right? And a specific VLAN is associated to a port with the command switch port access VLAN and VLAN ID, or else switch port access name and VLAN name. Clear? So both are the ways we can use. Okay, like this. Switch port access VLAN name and name of the VLAN, or else switch port access VLAN and VLAN ID. Clear? So let's see this thing practically. Okay, so we were going with the VLAN concept. So what I'll do with this switch, I'll connect a node also. Okay, or two nodes we can connect. This one is switch 2. This one is switch 1. Then two PCs I'm using. We'll change the names. Call it as PC1. And this one as PC2. Okay. Which one? And this one is switched. Close the gates. Guys, please settle down. Okay. So if we check it, one command is show VLAN brief. This is a command that gives us some information about the VLANs. Okay. Another command is we can say show VLAN summary. What happened? Okay. So when you use the command show VLAN summary, what do you get? Number of existing VLANs. So how many VLANs are there in total right now? 6, right? And number of existing VTP VLANs, we know VTP is what? A protocol that is used to synchronize the VLAN database, right? So for VTP also, how many VLANs are there? 6. And number of existing extended range of VLANs. So is there any VLAN from the extended range? No. So that's why it is 0. Okay. If you want information, guys, if you want information about a specific VLAN, you will say show VLAN. Okay. Then here you have an option for ID also. Okay. So I can say ID and I can say 10. Now this is the information related to VLAN 10 only. Okay. Where I get the information about VLAN name, status, and what ports are there. Okay. Then after, same thing you can do with the name also. You can say show VLAN name sales. So similar. This is clear. But majorly we use the command show VLAN brief. That gives us sufficient information we need to know. Clear? Okay. Now I have a VLAN and there is no port assigned to this VLAN. Correct? All right. Go to the global configuration mode. And let's say I'll go to interface gig 0/1. Okay. So as of now, the number of VLANs I have 1, 10, 1002 to 1005. Correct? So if I try here that switch port access VLAN and let's say 30. Now is the VLAN 30 there? No. So what my switch is going to do? It is first going to create the VLAN, then it is going to assign the membership, right? So see here, access VLAN does not exist, creating the VLAN 30. Okay. Check, do show VLAN brief. It has been assigned. This is clear. Okay. Now, let's say I want to assign the VLAN membership. One thing is we can assign with the number. Also, we can assign with the name. Okay. Now it says what? Native VLAN mismatch. Right now, why? Because gig 0/1 interface connected to the switch 2. So by default, switch 2 has VLAN number 1. And this guy has a VLAN number 30 configured. That's why VLAN mismatch is there. Okay. Okay. Now what I'm going to do is say switch port access VLAN, let's say 10 or 1. Okay. Anything we can say. So let's say I'll say 10. Now this port will be assigned to VLAN 10. Let's check. Yes or no? And if I want to assign the membership with a name, let's say, for example, interface gig 0/2 switch port access VLAN name, and name of the VLAN is sales. Let's check. Do show VLAN assigned. Okay. Now one more thing I'll try here. Gig 0/3. Okay. And I'll say sales. What it says. Means what? The name is case sensitive. The VLAN name is case sensitive. If it is uppercase, you have to write uppercase only. If it is lowercase, you have to write lowercase only. This is clear. Then if you want to assign, remove the membership, you can say we can use no, right? So what will happen? Do show VLAN brief. The VLAN membership. This is we said no, right? Okay. One more time. Interface gig 0/2. Okay, that's working. Interface gig 0/1. No switch port access VLAN. And we can see back to the default VLAN. This is clear. Now let's say if I go and check. So interface gig 0/0, let's for example. So I have to use the do. Why? Global configuration mode. If I'm using this command, do I have anything related to the VLAN or something? Yes or no? No. So how do I check the VLAN information? Like what is the port status and all? How do I check what is my native VLAN configured? What is my access VLAN? What is my like operational mode, administrative mode of the interface? You can check, right? That whether the port is access port or trunk port. How? How can I check? So interface number and detail. Detail. This one and detail. No. SW switch. What is SW? Switch. Sure. See, this is the problem. What is the issue? Let's say if we are telling you that, okay, for example, most people remember it as no SH. Why? Definitely this is shut down, but you have been told like this and you remember it like this. You never check that what it exactly means. What it exactly means. Like instead of saying switchboard access VLAN 10, I can say switchboard access VLAN 10. Now, are you going to remember it like this? That okay, SWAC VL10? No, right? So how, see here, that is not a switch, that is switch port. Okay. So you say show interface. Okay, I could also type these commands in short, but why do I always type them full? So that you can see and understand that what the actual command is. Otherwise, I could say here that okay, show interface 0/0 switch port. I could say that also, right? But this is show interface name, and then switch port. Okay. And if you don't know, you can question mark, right? Take a look. What is my access mode VLAN right now? Which is VLAN 1. And what is my trunking native mode VLAN? It is also 1. What is my administrative mode? Auto. What is my operational mode? Static access. What is the status of the switch port? And what is the name of the port? Right? Okay. Now what we'll do is interface, not here. Interface gig 0/0. Okay. And I'll say switch port access VLAN, let's say 10. Right? Now let's check again. Show interface 0/0. What happened? Access mode VLAN changed. Did anything else change? Like my switch port status, administrative mode, operational mode, or native mode VLAN? No, didn't change. Okay. Interface gig 0/1. Switch port access VLAN, let's say again 10. Okay. Do show interface gig 0/1 switch port. See, so whenever you change a VLAN membership, only your access mode VLAN is changing. No other characteristic is changing here. This thing is clear? Yes or no? Now here you see two things, right? One is your administrative mode and another one is operational mode. So what are these modes? What is the administrative mode and what is the operational mode? Why there are two different modes? You see here, right?
They're not actively informed from codes.
Okay.
It is dynamic desirable with multiple initial
Is it?
functioning.
Why there are two separate mode, administrative mode and operational mode? In your CCNA, you checked, right? This command you used, you didn't ask. Why? If you will not ask, we trainers will definitely ask. Right? Yes, tell me why two different modes? Anyone?
Operation mode is static access because by default it will carry only VLAN one, so it will take only
This is a guess or you actually know it? Hmm? Yes. Okay. You got this wrong. You see here two modes, right? One is the administrative mode, and another one is the operational mode. Now, you see here two things, right? Two separate things. Administrative mode is by default dynamic auto, and operational mode is static access. So when you use the command, let's say I use the command switch port mode access, which mode will change? Administrative or operational? If I say switchboard mode trunk, is it? Hmm? Which mode? Operational mode? Then what is the use of administrative mode? Hmm?
To negotiate between two connected.
No. See here. Your administrative mode, this is basically your configuration. Whatever you configure, switchboard mode, access, trunk, dynamic auto, desirable, everything. That is changing your administrative mode. And based on the administrative mode configuration, your port will start behaving. So this will show what? Behavior. This is showing the behavior of the port. That means, see here. By default, the switchboard mode is dynamic auto. That means here itself I can change dynamic desirable. How do you change? Switchboard mode, dynamic desirable. Same command you're using. Switchboard access, switchboard mode, access, switchboard mode, trunk, switchboard mode, dynamic, auto, switchboard mode, dynamic, desirable. Everything you are changing where? In the administrative mode only. Operational mode is auto decided based on your configuration. Based on your configuration. Now, another question is on a switch, what is the by default mode of a switch port? Auto. How many of you say dynamic auto? 1, 2, 3, 4. Yeah, this is fine. Yes, how many? Only few people. What about others? Hmm?
Auto.
Everybody says auto. But this is not 100% right? This is not 100% correct. Because in some cases, in some switches, it is dynamic desirable also. It is dynamic desirable also. Now the question is when? The question is when. So far you have seen dynamic auto? Yes or no? You have seen dynamic auto only. Why? Because you worked on only those switches which are running this mode by default. Correct? So what are the switches and where is this dynamic desirable mode? And in the interviews also, if you are asked that, okay, what is the by default mode of a switch port? So don't directly say dynamic auto, because might be the interviewer or in the organization, there are the switches where dynamic desirable mode is the default. Okay. So let me show you a note. Now, this might not be in your book. It is in the old CCI routing switching version 5 book. VLAN switching. Take a look. Read this note. Without any configuration, the default port setting on recent Catalyst switches series such as 2960, 3560, 3750, 3650, 3850. These are as follows. So on the recent switches, the mode is set to the native VLAN configuration is 1. Access VLAN is configured as 1. And the trunk encapsulation is set to auto. If the switch is supporting both ISL and .1 queue, then it will be either auto or it will be .1 queue only. Okay, ISL is not preferred. Either it will be auto or it will be .1 queue. Then all the VLANs will be allowed by default. On a trunk port will forward the traffic of all the VLANs by default, and VLAN 2 to 1001 are eligible for pruning. So I'll come to it, what is pruning. But as of now, you can understand that these are the configurations. So on the recent switches, what is the mode set? But on older switches like 2950 and 3550 models, the default mode was the dynamic. Clear? So in the interviews, when you are explaining about the default mode, you will explain it like this, that on older switches, the mode was set to dynamic desirable by default. But on the recent Catalyst switches, it is dynamic auto. Rather than directly saying dynamic auto. Clear? So you can make a note of it. These are the default configurations. Note it. Okay. Hmm? Yeah, depending. Most of them are L3 only. Yes. See, this is not the difference that okay, L2 switches will be dynamic desirable. No, no such thing. Okay. Most of the recent switches will be L3 supported. And even within the same series, like 2960 also, there will be different models. Okay. So this is clear that on the older switches, it was dynamic, desirable, and on the recent switches, it is dynamic. Okay. Clear? Then allowed VLANs, this concept we have discussed in the last session. That what are allowed VLANs? Each trunk interface will allow all the VLANs by default. However, VLANs can be removed or added to the list of allowed VLANs by using the command switch port trunk allowed, and yesterday we have seen. Right? Same way, to be active, a VLAN must be in the allowed list. Otherwise, VLAN will not be active. Right? The VLAN must exist in the VLAN configuration on the switch. Definitely, if the VLAN is not there in the configuration, then there will be no VLAN. And it must be in active state. Okay. So PVST, that is when we will discuss STP. That time we will discuss about it. Okay. So with PVST and an STP instance is actively running on this trunk for the VLANs in this list. That means whatever the VLANs are allowed, STP will also run for all those VLANs. This is clear? Okay. So access ports are clear. Then trunk ports, so we can use the command switch port mode trunk. So this is manual trunking right now. When you say switch port mode trunk on both the switch ports on both the switches, that is what? Manual trunking. And for automatic trunking, we have the DTP protocol. Correct? So this is the command show interfaces trunk that we can check. Now native VLAN. What do you know about native VLAN?
The feature of dot 802.12
Mhm.
it allows like by default it is VLAN one for all transports. It doesn't add 80.12 tag like NS26 of them. And by default it will like it's the receiving switch receives a frame without any tag. It assumes it belongs to
Native VLAN.
native VLAN.
So see, we have two tagging protocols. We have two tagging protocols. One is the ISL and second one is the dot one. Second one is the dot one. So major difference is, first of all, this is Cisco proprietary. Okay. This is Cisco proprietary and this is IEEE, or you can say open standard. Same thing. Then after your ISL, it adds 26 bytes header and 4 bytes payload. In each frame, it adds 26 byte header and 4 bytes payload. Correct? So that means overall, how much extra information it is attaching? 30 bytes. And we know that, okay, MTU is limited 1500 maximum transmission unit. So that means if the size of header is increasing, the amount of data will decrease. Frames will become bulky, right? So to avoid that, in case of dot one queue, only 4 byte tag, not even the header, only 4 bytes tag is attached in the existing Ethernet pin. 4 bytes tag is attached in the existing Ethernet pin. Okay. And even this 4 byte information, is prevented with the use of native VLAN concept. Because in case of .1 queue, native VLAN frames are not tagged. Here, native VLAN frames are not tagged. While here, in case of ISL, all frames are tagged. All the frames are tagged. Okay. So in case of ISL, doesn't matter to which VLAN it belongs, all the frames will be tagged. While .1 queue tries to protect or prevent or save even this 4 byte space by using the native VLAN concept. So what is the native VLAN concept? So native VLAN is a configuration on the switches. Okay. Let's say these are the two switches and I have a trunk interface. I have configured a trunk in between them. This is trunk. This is also trunk. Right. And according to trunk, we know that, okay, trunk interface will carry the traffic of all the VLANs, right? This will carry traffic of all the VLANs. This will also carry the traffic of all the VLANs. Now, the traffic of all the VLANs will travel through the single cable, single interface. Then how to segregate the traffic? That which traffic belongs to which VLAN. So to segregate the VLAN traffic, what is used? Tagging is used. What is used? Tagging is used. That means kind of a label is used on every single traffic that, okay, this belongs to which VLAN. This belongs to which VLAN. Now, if again all the VLANs are getting tagged, that means extra space is being used, extra memory is being used. Yes or no? So to prevent that, we configure here something called as native VLAN. We configure native VLAN, and by default, this native VLAN configuration is what? 1. And same thing by default here also. Your native VLAN configuration is 1. So what will happen? If there is any traffic on the switch, which is coming from VLAN 1, let's say for example, or first of all, let's say VLAN 10. Okay. If any traffic is coming from an interface which is a part of VLAN 10, so if this traffic has to pass through the trunk interface, my switch port will check that, okay, is it belonging to my native VLAN? Is it similar to the native VLAN? No. So what will happen? This will be tagged. This will be tagged, and this traffic will travel with this tag only. Okay. That, okay, this belongs to VLAN 10.
So can you please repeat again? Can you please repeat again?
Sure. Let's say we have an interface here. And this interface, let's say, for example, F0 by 1. And this F0 by 1 interface belongs to VLAN 10. Okay. And let's keep it aside for a while. Now there is a traffic coming through this interface. There is some traffic coming through this interface, and this traffic has to pass through the trunk interface. That means the destination is on the other side. So when this traffic will come here, the switch will check that, okay, this came from where? VLAN 10. And is it similar to my native VLAN? No. That means I need to put a tag here. And now it will travel with a tag. It's going to travel with a tag. So it will travel with this VLAN 10 tag, this side. Switch 2 will check to which VLAN it belongs. VLAN 10. So if VLAN 10 is configured on the switch, switch will forward the traffic. Clear? Now, let's say we have another interface. Okay. We have another interface. For an example, F0 by 2. And this belongs to VLAN 1 only. And there is some traffic through. Now there is some traffic that is coming from this interface. So when this traffic has to pass through the trunk interface, the switch port will check. The switch will check that, okay, it is coming from VLAN 1. Is it similar to the native VLAN? Yes. That means I do not need to tag this traffic. This belongs to the native VLAN. So this traffic will travel without any tag. Okay. This is what we mean that native VLAN frames are not tagged. That means if the interface VLAN is similar to the native VLAN, that traffic will not be tagged on the trunks. So here there will be no tag attached to it. So this will travel without a tag. Now the second switch will see that, okay, there is a traffic. Is it having a tag? No, no tag. And which traffic is untagged? Only native VLAN traffic. That means this traffic belongs to which VLAN? My native VLAN. So that means this traffic will be forwarded automatically to the VLAN 1. Is it clear? What is the native VLAN concept? If we want, we can change the native VLAN configuration also. If we want, by default, it is VLAN 1. But if we want, we can change the native VLAN. Okay, how can you change it? You can use the command. First of all, go to the interface. Interface name. And then you will say switch port from native VLAN. And here you will give the VLAN ID. This is how you can change the native VLAN. Clear? The native VLAN concept. That what is the native VLAN, why it is used? To save this 4 bytes. To save this 4 bytes. So that your traffic, if it is belonging to the native VLAN, it can travel without any tagging. No need of tagging that traffic. Clear? Okay. Now see here. In the 802.1q standard, any traffic that is advertised or received on a trunk port without the .1q VLAN tag is associated with the native VLAN, right? Okay. The default native VLAN is VLAN 1. When a switch has 2 access ports configured, okay, as access port and associated to the VLAN 10. Okay, see, this is an example. That you have a switch, it has 2 access ports configured as access ports and associated to the VLAN 10. That is a host attached to a trunk port with a native VLAN configured set to 10. The host could talk to the devices connected to the access port. What does it mean? It simply means you have a switch. On a switch, you have 2 access ports. One here, one here. This is access. This is access. And then you have one more interface, which is a trunk. Right? And let's consider there are 2 hosts here, host A and host B. And this is the third host, that is host C. Okay, this could be after another switch also, totally fine. This is A. This is B. This is C. And always remember, end hosts are not aware of the VLAN. That means they do not understand the .1 queue. End hosts, they are not aware of it. Okay. So if you have configured VLAN 10 here and VLAN 10 here, now these two, they can communicate. They can communicate. Why? Because access ports, same VLAN and same VLAN devices can communicate. But this is a trunk port. So that means when the traffic will pass through the trunk port, a tag will be there. A tag will be there. So if you want that, okay, these two hosts, host A and host B, should communicate with the host C, what we can do? We need to remove that tag. And how that tag will be removed? If I configured here native VLAN, so automatically this trunk interface is not going to tag the traffic. And if not going to tag, that means my host will understand the traffic easily. Is that clear? This is what it says here, that a host attached to a trunk port with a native VLAN set to 10. It could communicate with the two hosts which are associated to the VLAN 10. Okay. And remember, the native VLAN should match on both the trunk ports. Like if you have two switches, and both are connected using a trunk, the native VLAN should match. The native VLAN configuration should match. Okay. Or traffic can change VLANs unintentionally. Change VLAN means two different VLAN traffic can communicate. Okay. So while the connectivity between the host is feasible, this causes confusion for most network engineers and is not the best practice. Okay, this is also one of the questions interviewers might ask. This is also one of the questions interviewer might ask. Like they might ask you a question, something like, you have two switches connected to each other. Okay. Via trunk link. Okay. And there are two hosts connected here, host A, host B. Okay. So the host A belongs to VLAN 10 and host B belongs to VLAN 20. This is A. This is B. They are in the same network. Let's say, for example, 10.1.1.1, 10.1.1.2. This is switch 1. This is switch. Now, will they communicate or not? Why no?
Because there are two different VLANs.
There are two different VLANs. Now, the requirement is you have to provide communication without changing the VLANs. You cannot change the host VLANs, but you have to provide communication.
Then we have to create native VLAN on both the switches.
Okay.
And both native VLAN should be the same configuration.
Like what? What should we do? Inter-VLAN routing.
Right.
This is only the scenario. And inter-VLAN routing, you're telling me they are in the same network. So how will you provide communication here? Hmm? Yeah, you cannot change the host VLANs. Host A will be in VLAN 10 only, host B will be in the VLAN 20 only.
You have to add one more VLAN.
What VLAN?
10.
Okay, then connect the host B to VLAN 10.
Configure native.
Like if you want to configure native VLAN, how you will configure? What you will configure? On switch 1, what will be your native VLAN configuration? And on switch 2?
What I think if you have VLAN 10.
Hmm. But then your host B is not in the VLAN 10, right? Host B is in VLAN 20. Two different VLANs will not communicate. How will you provide the communication?
If we, in switch one, if we add VLAN 10, native VLAN,
Mhm.
there it's a VLAN 20, still it will show mismatch.
Mismatch it will show definitely. Okay. So this side, if you configure native VLAN 10, and here native VLAN 20, right? If you configure like this, so if there is a traffic from here, it will see that, okay, is it belonging to the native VLAN? That means will it be tagged? There will be no tag. So that means the traffic will travel from here. Without any tag, the traffic will travel here. When switch 2 will receive it, switch 2 will see that, okay, this traffic is not having a tag. That means to which VLAN it belongs? 20, VLAN 20 and VLAN 20 will have communication, right? So this is what it is saying that, okay, this might provide communication. This situation might provide you communication. See here, that while the connectivity between the host is feasible, it is possible, assuming that they are on different VLAN numbers. So connectivity might be feasible, but this can cause confusion for most network engineers, and this is not the best practice. So by configuring two different native VLANs, you can provide communication, but it will keep on giving you logs and warnings. For native VLAN mismatch will create confusion also, and this is not the best practice. Is it clear? And native VLAN is a port specific configuration. That means every single trunk port can have a separate native VLAN configured. Every single trunk port can have a separate native VLAN configured, and is changed with the interface command switch port trunk native VLAN and VLAN ID. This thing is clear? Online people clear? Guys clear?
Yes,
Right?
sir. Yes, sir.
So I believe now native VLAN concept is clear. If you want to change a native VLAN, we can simply just go and write, like right now we have native mode VLAN is 1. So interface big 0/1 switch port. So here you can see the trunking native mode VLAN is 1. Switch port mode trunk big 0/1. Switch port mode trunk, but here you can see this supports both. So we have to define one encapsulation. So switch port trunk encapsulation dot 1Q. Switch port trunk native VLAN. Okay, and let's say 10. This is the native VLAN. And without changing the native VLAN, if I'll show you the traffic, right? So let's say no. Do show interface gig0/1 switch code. So we can see right now native mode VLAN is one only. Okay. And on the switch to interface gig0/1 switch port mode, switch port trunk encapsulation .1q and switch port mode trunk. Okay, so we can see here to show interface gig0/1 switch. So here also interface is trunk and native mode VLAN is 1, right? Okay. Now what I'll do, I'll start a packet capture on the Z0/1 interface. And both of these hosts, PC1 and PC2, I'll add them in the VLAN 10 only right now. Okay. So on the switch 1, interface gig0/0 switch port access VLAN 10. And same thing here. Interface gig0/0 switch port access VLAN 10. Okay. So both of Z0/0 interface have been added to the VLAN 10 and Z0/1 is trunk with native VLAN configured as 1. Okay, and I'll configure IP addresses 10.111, 10.112. This is PC1. So here I'll configure 10.1.1.1. And on the PC2, I will configure 10.1.1.2. Okay. And here our packet capture is already going on, right? Now I'll try to ping from PC1 to PC2. Okay, this is a bit small, so I'll just type in ping command. 10.1.1.2. Here you will just take a look at ICMP traffic. Okay. Now this is Linux, so we have to stop it. Otherwise, it will keep on sending. See here. This is 10.1.1.1 trying to send an ICMP to 10.1.1.2. And do you see something here? The .1q tag is there. Why? Because right now native VLAN configuration on both the switches is 1. And we are sending traffic for VLAN 10. Correct? We are sending traffic for VLAN 10. So you can see here VLAN ID information is there. If I expand it, this is the VLAN ID, which is 10. Correct? Same thing. Now, if we change the native VLAN, you will see that after this, we will not see the .1q tag. Okay. Now here, okay, now you see that there is no ICMP here as of now. Or let me just restart the capture. Okay, now you see there is no ICMP. And first we will go and change the native VLAN on both the switches. So interface gig0/1 switch port trunk native VLAN 10. Okay. This side also interface gig0/1 switch port trunk native VLAN 10. Okay. So now we can see here that do show interface v0 by 1 switch port. My native VLAN configuration is 10 here, and same thing, show interface z0 by 1 switch port. Here also it is set to 10. So this time when I'll send ICMP, right? You can see right now no ICMP traffic. Now I'll try to send ICMP again. Okay, so you can see I have communication. I got some ICMP traffic. And in this ICMP traffic, now you will not see any tag here. The .1q tag will not be there. Why? Because there is no tagging now. Traffic is belonging to native VLAN. So there is no tag at all. This is clear? Yes or no? Another thing you might have noticed when I changed the native VLAN, I got a log. That received BPDU with inconsistent peer VLAN ID on the gigabit interface Z0 by 1 VLAN 1. Okay, this is switch 2 saying that, okay, I have received a VLAN ID 10 and our VLAN is 1. Then what it did, blocking Z0 by 1 on the VLAN 10, inconsistent peer VLAN, STP will block it. If we change the native VLAN, STP will block that port. So if you want communication by just changing like this condition, if you want to achieve, where you change the native VLAN to different native VLANs. So by default, STP will block it. So what you will have to do, you will have to disable STP on these ports. Then after you will be able to have communication. But this is not the best practice because too much of extra configuration. Is that clear? What is the best practice? That your native VLAN on both the sides must be safe. This is clear. Native VLAN is clear that if the frame belongs to native VLAN, it will not be tagged. And if it does not belong to native VLAN, it will be clear. Online people?
Yes, sir.
Okay. Then allowed VLANs we had discussed. MAC table. So how a switch populates the MAC table? That also I think we have seen in the last session. If you want to clear the MAC address table, okay. So you can say clear MAC address table and dynamic. Okay. So see here, these comments we will discuss. So we can use the comment show MAC address table. This will show us what? Your CAM table. Okay. If I go on the switch and if I check, if I say show MAC address table, it will show me the entire MAC table. If you want to see only dynamic entries, so you can say show MAC address table dynamic. This will show you the dynamic entries. So right now I have dynamic entries only. That's why it is showing what? Dynamic. Okay. Sometimes, you know, like MAC spoofing kind of attacks can be there. Okay. So you can make static entries also. You can make static entries also, because if you will make static entries in the switch that, okay, on this port, this MAC address is connected. Okay. That will provide you higher level of security. Okay. So we can even make static entries. How? So you can use the command here. Take a look. You can use the command MAC address table static, then you can give the MAC address, VLAN and VLAN ID. Okay. So this will add what? This will add a manual entry with the ability to associate with it with a specific port. Or else if you want to drop the traffic of a specific MAC address, that also you can. Okay. Now take a look. let's say I'll just add a random MAC address here. So I'll say MAC address table, and I want to add a static entry. Then what it is asking me, MAC address, let's say this is the MAC address. Then to which VLAN? So this is the VLAN keyword. Now which VLAN it belongs? Let's say VLAN 1 it belongs. Which interface? So on which interface? Let's say Z0/2. Then we can hit enter. Done. Check. Do show MAC address table. Now you can see I have added a static entry also. Inside the CAM table, I have added static entry also. And now if you say MAC address table dynamic, sorry, it will show you only dynamic entries. If you say static, it will show you static entries only. And if you don't say anything, it will show you all the entries, right? If you want to clear the MAC address table, okay, so you can say clear MAC address table. Okay, so this will clear. No, you have to use static entries cannot be cleared. You have to remove it using the comments, using the no comment. Dynamically, you can remove all the dynamic entries you can remove. So if you use the command clear MAC address table dynamic, this will remove all the entries from your CAM table. This will remove all the entries from your CAM table. That means all the dynamic entries. If you want to remove a specific entry, then you have to give the address. If you want to clear dynamic entries from a specific interface, that you have to mention. Okay. So if I say dynamic, you will see that entire MAC address table dynamic entries are cleared. I was having 2 dynamic entries here, right? So now if I say show MAC address table, you see I have only static entry. Okay. Again, I'll try to provide communication. Now switch again got 2 dynamic entries. Or you can see 3 dynamic entries I have, right? Now let's say you want to clear only a specific entry. Only a specific entry you want to clear. So we can say dynamic, okay? Then you can say address. Now you can give the MAC address here. Let's say I just want to clear this 003 MAC address. Okay. And just hit enter directly. Now see here, only that one is cleared. Right? If you want that, okay, all the things associated with this interface you want to clear. So instead of saying this, I can say interface and Z0/1. Take a look. All the entries from the Z0/1 interface has been cleared. Clear? Same way, you can clear everything related to a particular VLAN also. Let's say VLAN 1 entries I want to clear, so I can clear that. This is clear. How you can play around with the MAC address table, how you can add static entries, and how you can clear the entries. Okay, you can clear an individual entry. You can clear entries related to a particular interface or a particular VLAN also. Right? Yeah. Static means fixed. You have to manually provide it. Okay. So the MAC address table resides in the CAM, and the CAM uses high-speed memory that is faster than typical computer RAM due to its search technique. That's why your switches are faster, right? The CAM table provides a binary result for any query of 0 for true and 1 for false. Okay. Switchboard status. So switchboard is status whether it is down or up. Okay, so how we can check? We can say show interface, interface ID, and switchboard. Okay, so whether it is enabled, disabled, it's administrative mode, it's operational mode, those all things we can check, right? Then you can use the command show interface status. So that will tell you whether this port is in a particular VLAN or it is a trunk port. For example, take a look. If I say show interface status, so our Z0 by 1 is a trunk interface. So that's why it is showing trunk. Then Z0 by 0 belongs to VLAN 10. So this is VLAN 10. Okay. And remaining all ports in the VLAN 1. Speed is auto negotiated. Duplex is auto negotiated. And currently it is full duplex. And the connector type is RJ45. VLAN ID is 10. Interface status is connected. And port is Z0 by 0. Clear? And this command also we have seen Z0 by 1 switch port, let's say. So here you see it is dynamic auto and operational mode is trunk. Okay. We can change it. I can say configure terminal interface Z0 by 1, let's say. Switch port mode access. Now, when I say switch port mode access, I have changed the administrative mode. Okay, so according to administrative mode, automatically my operational mode will change. So if I take a look, show interface gig 0/1 switch port. Take a look. Changed. Okay. And if I say switch port mode trunk, now you see my administrative mode is trunk, and according to my administrative mode, my operational mode is there. Same thing I can say that, okay, switch port mode dynamic auto. Okay. So I have changed it to dynamic auto. So what I am changing? I'm changing the administrative mode. And according to my administrative mode, my operational mode is changing. Clear? Then next is about L3 forwarding. Okay. So L3 forwarding is about the router, so we'll not discuss this one. Okay. So this was about our chapter number 1. Now DTP and VTP2 protocols are there, which we are going to discuss before STP. Okay. So these two protocols we will discuss more. Okay. Because battery is almost about to die. Clear? Online people, so far any doubt?
No.
Okay. So we'll wind up for today's session.